deviation from it with and minimum deviation, right? So we derived the formula for minimum deviation, which was delta is mu minus 1 into area. Kilo press 1 minus 1 into it. We have seen that. So generally what happens, we know that there is a formula which is Cauchy's formula, and according to this formula, the refractive index of a material depends on the wavelength, right? If you see this formula, can everyone see the screen? Screen is visible to everyone. So what happens when wavelength of light increases, the refractive index of a material decreases. If you see from this formula, the you see here the refractive index N or mu depends upon wavelength, right? So it is clear that when lambda will increase, refractive index N, or we can also say mu, will decrease. So it is not same for all color of light, right? Or for all kind of electromagnetic waves. So it depends upon the wavelength. Wavelength of light increases. We know that light is of different wavelength for different colors. It is maximum for the wavelength of light is maximum for violet color, and minimum for violet color, and wavelength of light is maximum for red color. We already know that. I think lambda is maximum for red color, and lambda is minimum for violet color. So if you see from this formula, for red color light, what will happen? N will be minimum, right? And for violet color, N will be maximum. It means violet color of light will be deviated most whenever passed through a prism. The maximum deviation will be for violet color, and the minimum deviation will be for red color. This is it. So you can see the diagram also if you if you remember the spectrum of light which you have studied in, I think, class 8 and 10 also, when light passes through a prism, the light gets splitted, right? So this is mainly because of the refractive index is different for different color of light. So it is obvious that different color of light will go through different deviations. And if you remember the spectrum, you have seen like violet is always on lower side and red is at the top. So the reason behind is violet color is getting maximum deviation and red color will get minimum deviation. As we have seen from the formula, lambda is maximum for red, therefore deviation is refractive index is minimum for red. That is why red color is deviates minimum and violet color deviates maximum. And we are getting this kind of spectrum which you have seen last 10. So this is the basic cause, and that will lead to dispersion, which we are going to study further. What is dispersion and all. So till now everyone understood why different color of light deviated by different angle. Everyone getting the point? Because if you see from the formula, delta is equal to mu minus 1 into A. We have seen the formula for deviation, right? Delta is mu minus 1 into A. So it is maximum for violet color, right? So delta is maximum for which color? Violet color, and delta is minimum for red. Got it? So everyone understood this one? Anyone having any doubt? So that is why the pattern which we are getting in this range, violet is always on the lower side of the spectrum because it is maximum deviation. So now the thing comes, that is dispersion. So now let us see dispersion. Someone is asking, it is class 12. You all are in class 12, right? Yes, it is class 12 batch. Anyone having doubt of class? All right. Now coming to the, quickly we will come to dispersion, then we will move to reflection. So what is dispersion? The phenomenon of splitting of white light into its components color on passing through a medium is called dispersion. Obviously we have seen that different color of light will face different kind of deviation because of refractive indices. More is the refractive index, more will be the deviation. As we have seen, for violet color deviation is maximum, and for red color deviation is minimum. So when a white light, we know that white light is a combination of 7 colors. So when a white light is passed through a prism or any kind of transparent medium, it will split into different components, and this is phenomenon of splitting of white light into its component color is known as dispersion of. So very basic definition you have to remember. So this was I was trying to explain. You can see here how light is deviated. For violet color, we have seen that mu is maximum, right? So if mu is maximum, obviously if it is maximum, deviation will be maximum. So for it is, for violet, delta is max. For red color light, delta deviation is, that is why it is on the top and violet is on the bottom. So this is how a white light gets splitted while passing through a prism. I think all of you understood, right? Anyone having any doubt, please ask. Now moving to the next section, that is angular dispersion. What is it? Angular dispersion, uh, angular separation between violet and red color in the spectrum. So it is very obvious from the definition also, or from the term itself, angular dispersion. It means the angular separation between violet and red color in the spectrum. So if you see this spectrum, violet and red color suffers different deviation. So suppose you know that this one is violet and this one is red. So if you produce this one in the backward direction, suppose it is making delta V, and for red color, suppose deviation is delta R. So what will be the angular dispersion? It will be delta violet minus delta red. You know that deviation for violet color is more, so we will take the difference, delta theta or delta we can say. So theta is the angular, if we say theta is the angular dispersion, so it will be the difference of deviation of violet as well as red color, right? Then we will simply put the formula delta is equal to A mu minus 1 and A n minus 1 or mu minus 1. So for violet color, obviously we will write refractive index NV, and for red color it is NR. So we will rearrange the formula and we will get the angular dispersion as A into NV minus N. So this is the formula for angular dispersion. Anyone having any doubt, please ask. So can anyone say when this formula will not be valid? Will this formula be applicable for all kind of prism, or is there is a condition to apply this formula? Can we apply this formula for all cases?
No, sir.
Anyone?
Only between violet and red color.
That is true for violet and red color. Angular dispersion is defined by violet and red color. That is okay, but I am asking, will it be applicable for all kind of transparent materials, or for all kind of prism, or for a particular kind of prism? So you have to be very clear about it, that this formula is only applicable for thin prism. For thick prism, you cannot apply this formula. You know what is the basic foundation of this formula? How this formula has been derived? By using delta is equal to n minus 1 into a, right? And this formula is only applicable for thin prism, right? We have seen that. So this formula is only applicable in case of thin prism. For a general prism, the deviation for mu is equal to sine A plus delta m by 2 divided by sine A by 2, right? This formula for deviation was a special case of thin prism only. And what is the thin prism? When angle of prism varies between 1 degree to 5 degree, not more than that, right? If angle of prism is in the range of 1 degree to 5 degree, then and only then the prism can be considered as thin prism, right? Everyone got it? So you have to be very careful that you can only apply this formula in case of thin prism. For thick prism, it is very difficult to find the angular dispersion and all. We cannot derive the relation at this stage. So we have to consider the thin prism. Got it? There is another definition that is mean deviation, which is defined as the. So it is very clear, obvious from the term itself. Mean deviation means we have to take mean refractive index, right? And how mean refractive index is defined as? It is the average of refractive indices of. We define mean refractive index, which is the average of violet and red color, and it is approximately equal to refractive index of yellow color. You can also see the yellow color. Yellow color is light in mid of the spectrum, right? If you see the spectrum from violet to red, basically yellow lies in the middle. So that is why uh, if you take the average of refractive indices of violet as well as red color, automatically you will get the value which is equal to refractive index of the yellow color. It doesn't mean that the formula for yellow color deviation is average of that. Well, actually that is not a definition, but by default, if you take average value, you will get this value nearly equal to refractive index due to yellow line. So the mean refractive index can also be taken as refractive index of yellow colored light, and that is why we define delta mean is equal to a mean minus 1, and this mean refractive index approximately equal to refractive index due to yellow color. So the mean deviation can also be defined as a into refractive index of yellow color minus. Got it? All right. The next term is dispersive power. That is the ratio of angular dispersion by mean deviation is also known as dispersive power. And you can see we have to put the formula for angular dispersion and the mean deviation, and you will get omega, that is dispersive power as NV minus NR divided by NN minus. Can anyone say me the unit? What will be the unit of dispersive power? Anyone? What is the unit of dispersive power? Anyone? What will be the unit of dispersive power? No unit, right? It is the ratio of dispersion and mean deviation. Both are angles. Delta V minus delta R is also getting my point. Both are angles. Ratio. It is the ratio of same kind of physical quantity. So no unit, no dimension. No unit, no dimension. So anyone having any doubt till now? I am going to end this topic, dispersion, and we will start the new section. So anyone having any doubt till now? Should we go ahead?
Yes, sir.
All right. So now we will move to the next topic, that is reflection. So you all have studied in class 10 also, 8 also. So can anyone define what is reflection of light?
The striking back of light, bouncing back of light rays and striking a reflecting surface.
The bouncing back of light after striking a reflecting surface. Yes, up to some extent. It's a good definition. Or you can also define it like the returning of light after incident on a surface. The returning of light or the bouncing back of light in the same medium. This is very important. Light bounces back in the same medium in case of reflection. Or the bouncing back will also work. You can give the definition like that. Bouncing back of light after striking a reflecting surface as reflection. So yes, true. So that is the definition of reflection, bouncing back of. I'm not writing the definition. You all know the definition. So now, if you see the kind of reflection, right? So what is reflection? I'm writing in short, bouncing back, bouncing back. All of you will understand. So bouncing back of light after striking a reflecting surface is known as reflection. Now we know that there is generally, if you see majorly, there are two kinds of reflection. One is regular reflection, another is diffused reflection. So what is regular reflection? When light strikes a plane surface, right? Reflection from a plane surface is known as regular reflection, and reflection from a diffuse, in case irregular surface, right? Whenever light strikes a irregular surface, then the reflection is known as diffuse reflection. So can anyone say, will the law of reflection will be valid in case of diffuse reflection? Anyone?
Yes.
Will it be valid?
Yes, sir.
Why? The surface is not plane. Yes, you are correct. Law of reflection is valid in case of diffuse reflection also. Sometimes we get confused that in case of diffuse reflection, law of reflection is not valid, but this is not so. This is a misconception. The law of reflection is valid in both cases, in regular as well as diffuse. And the major, if you see, generally in case, the regular reflection is the ideal case, but in day-to-day life, generally we see diffuse reflections. If we see the surfaces around us are not so plain, right? Walls and kind of objects, these are not plain surfaces, most of these surfaces. So in day-to-day life, most of the reflections are diffuse reflections. We see reflections from like, water surfaces which are not, water is flowing there. The surface is not completely smooth. The surface is kind of wave kind of a structure is having. Or if you see walls, or if you see when after rain, if you see different leaves, water droplets are there on the leaves of the tree, and those are zigzag kind of things. So those are also kind of diffuse reflections. So law of reflection is valid in both the cases. Now, if we see, we have the idea of law of reflection. What are the laws of reflection? There are two laws. We all know that. That is, the first law is angle of incidence is equal to angle of reflection. And the second is the incident ray, the reflected ray, and the normal. All the three lie in the same plane. That is the second law. So you can see the diagram here. The angle of incidence I is equal to angle of reflection. This is the first law. And the second law is incident ray, normal, and reflected ray all lie in the same. Incident ray, normal, and reflected ray all lie in the same plane. Right? So this is the law of reflection. If you see here the angle of deviation, what will be its value? Can anyone know how to calculate this? If you want to calculate this from the diagram, it will be 180 degree minus I plus R, right? This is the angle of deviation. And we know that in case of reflection, I is equal to R. So that will be equal to 2I. Or it will be also equal to 2R. So the angle of deviation is 180 minus 2I or 180 minus 2R, right? If an angle of incidence is given, you can find the deviation due to. So what happens? Actually, light gets reflected. Obviously, it is deviated from the original direction, and that is known as angle of deviation, and that is equal to 180 degree minus 2I or 180 degree minus 2I. Got it? All of you understood how I have calculated the deviation?
Yes, sir.
So this is important. Sometimes numerical is asked from to calculate the deviation, or sometimes you have to derive. We can derive it like this. You have to show the diagram. All right. Can anyone say if angle of incidence is like if you see the diagram, like if a light ray incident like this, so what will be the angle of incidence and what will be the angle of reflection?
90 degrees.
90 degrees, right? Anyone else?
No, sir, 0 degree because angle of incidence will be
Correct.
0 plus normal.
We get confused. Angle of incidence here is 0. So what will be the angle of reflection? You know, we always know that I is equal to R. The I is R will also be equal to 0. What will happen? The light ray will get back along the same line. So I and R both will be equal to 0. Got it? All of you understood why I is equal to 0 and R equal to 0 in this case?
Yes, sir.
All right. To give you one example. Okay, later on I will give you time permits. I will give you one or two examples to solve. Okay. Now moving to the mirror. So after the definition, going through the definition, now we have we have studied what is reflection, what are the laws of reflection. Now moving ahead, the best surface or the best optical device which is used for reflection is mirror, right? Generally, most of the cases with the see reflection from mirror. So generally we have two type of mirrors, that is plane mirror as well as spherical mirrors. And we also know that a spherical mirror is again two type, that is convex and concave, which we are going to study later on. So now coming to the plane mirror, we know what is a plane mirror, having a reflecting surface is flat, right? For a plane mirror, reflecting surface should be flat. That is plane mirror, and one of its part is polished, and other surface from the other surface reflection take place. So to have a generally what we do, we have a transparent material and we polish it. So the reflection will take from opposite side. So reflection will take from this side, right? Reflection always takes from opposite side of the polish. So if one side is polished, reflection will take from the other side. So this is basically kind of plane mirror. Now and we know that in case of plane mirror, the object distance and image distance are equal, and image is always formed I will explain you here. If you see here how image is formed, suppose this is an object, and how we will form the image? You have to take two light rays, right? One light ray is taken like this. It is coming perpendicular to the mirror, so it will get reflected back, and the other is kind of this. You can take second ray like this. So if you produce these rays backward, you will get the image, right? So it should be dotted here. So basically it is a virtual image, right? It is a virtual. So in case of plane mirror, virtual image is formed, and also you can see u will be equal to v, right? If you use the geometry, like suppose this angle is theta, this angle is theta. So again, what will happen? This angle will also be equal to theta, right? So from the triangle, you can see that height of object is equal to height of image. So h by u will be equal to h by v. If you see from the geometry of the figure, so you will get v equal to u, right? So in case of plane mirror, the image distance is same as the object distance, and it is virtual, right? Everyone got it? Anyone having any doubt, please ask. And please answer one of my question. Can we have real image in case of plane mirror? Can we have a case where real image is formed by a plane mirror?
No, sir.
No. Are you sure?
Yes, sir.
I will give you an example. Suppose I have a mirror like this. Suppose a light ray is coming like this. So it will get reflected like this, right? Got it? So here, if you draw it backward for this mirror M, this will act as object and this will be the image. Now see this diagram clearly. The object is virtual or real? If you see here this image is real, right? So whenever the object is real, then image formed by a plane mirror is virtual. But if object is virtual, then it may form real image. Got my point? If object is virtual, a plane mirror can form a real image. Generally, we skip it and we only remember that a plane mirror forms a virtual image, but this is not always true. In 90% case, we take real object, so that is why we call it virtual image. But a plane mirror can also form real image. Got my point? So now onward, you remember this. Plane mirror can form a real image. But the case is the object should be virtual. Understood?
Yes, sir.
This is very important from competition point of view. All right. Here it is written, right? Image is virtual if object is real. Now there is a very important result which you have to remember. I don't have much time to prove that one. can also be proved, but you can remember it will be okay. Like if you want to, suppose you are standing here and you want to see, and this is a mirror, and if you want to see your full image, right? You are getting ready for a party, and if you want to see your full image in the mirror, you cannot take a tiny mirror, right? You have to take a mirror which should be at least half of your length. If you are 6 feet tall and you want to see full image of yours, what should be the height of mirror?
At least 3 foot.
Yes, at least it should be 3 feet. Got it? So if you are 6 feet height, it should be 3 feet. Got it?
Yes, sir.
A man of height h require a mirror of length of equal to h by 2. H by 2 say if your mirror height is less than h by 2, you can't see the full image. You can see the image, but you will not be able to. कहीं से पैर कट जाएगा, कहीं से सर कट जाएगा. So you will not be able to see full image. So, yes. I'm giving you a homework. Think about it. Suppose you are standing in a room, right? There's a homework. Think about it. And there is a wall behind you. There is a wall behind you. And there is a mirror in front of you. So what will happen? You will see image of the wall in the mirror, right?
Yes, sir.
So what should be the height of the mirror? Suppose height of the wall is h. So you have to find the height of the mirror so that you can see full image of the wall. You can see full image of the wall. Right at your home. It is a homework. Think about it. You are standing in a room. Behind of you is a wall. In front of you is a mirror. And you want to see full image of the wall, not your image. You want to see full image of the wall. Then what should be the minimum height of the mirror? Getting my point?
Yes, sir.
You try to find it. Actually, it should be h by 3, at least third of height of the wall, right? It should be h by 3. But you try to find it how it comes again. In case you want to see full size of your image, it should be h by 2. But if you want to full size, you see the full size of image of your wall behind you, the height of mirror should be 3. Try to find it how it is. I've just read it in. I don't have much time to derive that. It can be derived. It will be sufficient if you actually these points are important for competition. So at this point of time you can. All right. So we have seen the image formation by a plane mirror. Also, one point you should remember that whenever you are moving in front of a mirror, and if the mirror is stationary, then the speed of object is always equal to speed of image. Suppose you have a plane mirror and you are moving with velocity of 4 meters per second in front of the stationary mirror. What will be the velocity of image? Same, 4 meters, right? You can try it. You can see in the mirror, and you run in front of a mirror, your image will run towards you with the same speed. Got my point?
Yes, sir.
Can anyone say what will be the velocity of image with respect to object?
Opposite. Minus.
Opposite is correct, but that is direction. But I am asking, what is the magnitude of velocity of image with respect to object? Think about it. If you want to find velocity of anyone with respect to other, what we will do? We will subtract it. Velocity of image minus velocity of object. What is velocity of image? -4. What is velocity of object? 4. So we'll get -8 meters per second. So the object will see the image moving towards him with speed -8 meters per second. Got it? With respect to ground, velocity of object and image are equal. But if you want to see velocity of image with respect to object, what will be that? -8 meters per second, twice of that. Understood?
Yes, sir.
So this is the case. Very interesting things are there, but don't have much time to teach those things. Anyway, all right. Now we will see reflection from a spherical mirror, right? Till now we have studied reflection from plane mirror. Now you can see reflection from a spherical mirror. So you all have idea of what is center of curvature, what is radius of curvature, right? You know that what is pool, what is. So basically what happens, a spherical mirror is a part of a spherical, like suppose you have a transparent sphere, right? And suppose you have a transparent sphere, and if you have a transparent sphere and you polish it, so if like, so basically what happened, it is a part of a sphere, right? It is part of a sphere and one side is polished. So if reflection take place from other side, right? So if reflection take place from curved side, then it is from this side, concave side, then it is known as concave mirror. And if reflection take place from convex side, it is known as convex mirror. So I think all of you are clear what is a concave mirror. Right? Disappears. I think it disappears by itself.
Sir, in
Anyway.
semiconductor devices, transistors part is there in syllabus for CBSE?
Sorry?
Sir, in semiconductor devices, chapter 14, transistors is there for board exam syllabus?
Transistor, I think transistor is not there in CRT.
Because in omitted portion is showing only for LEDs and Zener diodes, not showing
Yes,
about
sir. I think
transistors.
I'm not much sure. I have to check it. But I think it is not in the syllabus. Transistor. You have to see the latest syllabus. You can download it also. I'm not much pretty sure, but I think it is. It has been omitted because in the newer NCRT, the transistor is not there. Right? Logic gates are there, diodes are there, but transistor is omitted. Got it?
Yes, sir.
So if you know the definition of mirrors, right? So there is a problem in writing. So you understand it by this. You know, you can see in the books I am writing it disappears. So let me share it again. Disconnect and share. Pause. So in case of reflection, generally what happens if reflection takes place from the concave side, that is known as concave mirror, and if we polish in such a way that reflection takes place from the convex side, then it is known as concave. Now there are two kind of relation which we are going to derive right now. One, we know that focal length is half of radius of curvature that we are going to derive, and the second is mirror formula. That is very important. So both of the two relations we are going to derive. So before that, I will give you a brief idea of a spherical mirror and how image is formed in case of spherical mirrors. Then we will do the derivations at the end of the class. So, anyone having any doubt till now? Please ask. When is your board exam? I think in Feb, the date is announced, right? Or in can everyone see this screen? Let me start my own board below. So we have seen mirrors as well as windows. Okay. Now, if we see, so the sign convention, that is very important. So we know that I, before going into in the definition, let me brief you how sign convention works. So what happens in sign convention is so generally what we take this point as origin, right? Take the pole as origin. We know the definition. All of us know the definition. What is pole? Pole is the center part of the uh, you know mirror, mid part of the mirror we can say, or C is the center of curvature, which is the center of the spherical part of which the mirror is a part. So the center of that spherical part is the center of curvature, and r is the radius of curvature. This is the radius of the spherical part. Generally, what we do, we take pole as the origin and the direction of incidence light as the positive direction. So the direction of incident light will be taken as positive direction and pole will be taken as origin. So obviously right direction will be positive, left direction will be negative, and upside part from the principal axis simply assume as like x, y, z axis, right? Like upper part is taken as positive and right side, generally direction of incident light is taken in the right side. So actually we take the direction of incident light as along x if you assume. So right side will be taken as positive and upward direction will be taken as positive for both the convex and as concave. So this is the sign convention and this is written here. All distances, obviously all distances are measured from pole. Distances measured in direction of incident light is taken as positive and opposite is taken as negative, and distance above principal axis is taken as positive and below principal axis is taken as negative. So all of you I think understand sign convention. Anyone having any doubt in sign convention? I think all of you understand that. Now if you see focal length, what is focal length? So if a parallel beam of light incidents on a spherical mirror, what happens? It passes through a common point or it converges at a common point, that is known as focus, and the distance between pole and focus is known as focal length. You can see from here, and we also now know that. So same can be defined in convex mirror also. In case of convex mirror, the focus lies towards right, and in case of concave mirror, the focal lies towards left. And we also know that f is equal to r by 2, which I am going to derive. So after that, I will move to the mirror formula. So before that, let me derive how we get f is equal to r by 2. And also, I think you are aware of some image formation in concave mirror. If you see image formation in concave mirror, I will give you a brief idea about that. Image formation in concave mirror. How images form? There are some rules for image formation. So quickly, I'm giving a brief idea. You know that, like if a light ray is traveling parallel to the principal axis, what happens? It passes through focus. And the second is, if a light ray passes through focus, if a light ray passes through focus, it will become parallel, right? If a light ray passes through focus after reflection from the mirror, it will become parallel to the principal axis. And the third thing is, if light ray passes through principal axis, sorry, center of curvature, so it will get back in the same path. If a light ray passes through center of curvature, it will retrace its path. It will revert back along the same line. So these are three things and the fourth thing is we will use in the image formation is like this. If light ray comes like this, if light ray comes at angle theta, it will move at angle. So these are the basic rule which will be used for image formation in case of concave mirror, which you all know. One is ray passing parallel to the principal axis will pass through focus. When a ray of light passes through focus, it will get parallel to the principal axis. And when a ray of light passes through center of curvature, it will retrace back. Or if it is falling at an angle theta, it will reflect at angle theta. And generally what will happen, we will take paraxial ray, right? We are taking paraxial rays. This is very important. All your formulas and derivation are only applicable in case of paraxial rays. Paraxial rays means the rays which are very close to the principal axis. That is very important. Those approximations which we are going to use. So now coming to the main part, we have to derive how we get F equal to R by 2, right? We are going to derive that. So for that, let us see what we will do is, suppose I have a concave mirror. Suppose I have a concave mirror. And suppose this is the principal axis, and suppose the ray of light is coming parallel to the principal axis, passes like that, will pass through focus. Suppose this is the center of curvature, this is the pole. This will be normal. When we draw a line from the center of curvature, it will always normal to the mirror, right? Because that is the center. Suppose this angle is theta. What will happen? This angle will also be equal to theta, right? Suppose this point is A. So what will be this angle? And also this angle will be equal to theta, because reflection is taking place. So that angle will also be equal to theta. So what will be this angle? This is the exterior angle of a triangle AFC, right? So what will be this angle? This angle will be 2 theta. Everyone understood this? Anyone having doubt, please ask.
Sir, how is angle C theta?
Which angle?
C.
This angle.
Yes, sir.
This ray is parallel to the principal axis. If you see this ray, it is parallel to the principal axis. So if this angle is theta, this will be the adjacent angle, right? So if this angle is theta, this will be theta.
Yes, sir.
If two lines are parallel, let me draw a line. This angle is theta, this line is always theta. Same thing is here. Got it? Now, if this is theta, this will also be theta, because this is the angle of reflection. And have you understood how it is 2 theta?
Yes, sir.
It is the exterior angle of the triangle ACF, right? So, detail you can write. I will derive directly, and I will, how to write the thing. You can write like, suppose M is a concave mirror, and you can write here. And if you want to do you have notes for this? Do you want to write a notes for this, or should I explain? So if you want to write like notes, you can write here. Let us assume a concave mirror M. We can write here suppose let us assume a concave mirror M and a light ray incident, and a light ray is incident parallel to the principal axis at an angle theta as shown in the figure. Now from the diagram, it is clear that Cp equal to theta. Therefore, exterior angle of the triangle, ACF, that is AFP, will be equal to angle ACF plus angle CAF. What is angle ACF? That is theta. What is angle CAF? That is theta. So angle AFP will be equal to 2 theta. Now, what we have to do now? Now in triangle, ACP. Non-triangle ACP, what we can write? And what also you can do, draw a normal from A to principal axis. Suppose this normal is N. So draw a normal AN on the principal axis. So now in triangle ACN, what we can write? We can write tan theta will be equal to AN upon CP, AN upon CN, right? This all of you understood how we got tan theta is equal to AN by CN? Similarly, in triangle AFN, what we can write? We can write tan 2 theta. Tan 2 theta will be equal to AN upon FN, right? In triangle AFN, we can write tan 2 theta is equal to AN upon FN, right? So let us assume this equation 1, or not say equation. Now let us take assumption like that. Now what we can write? Now for paraxial rays, what we can write? We can write tan theta is approximately equal to theta, and that is N upon CA, right? This is equation 1, and tan 2 theta is approximately equal to 2 theta, and that is N by F. Okay, this is equation 2. Now from 1 and 2, what we can write? Now from 1 and 2, what we can write? N by Cn. Twice of N by Cn will be equal to N by Fn, right? All of you understood it? How I have written this? From 1 and 2, what we will get? twice of an by cn will be equal to an by fn, right? Because theta is an by cn and 2 theta is an by fn.
Yes, sir.
Means an by fn is equal to 2 an by cn. So from here we can write cn will be equal to 2fn, right? Cn will be equal to 2fn. Now we can see that n and p are very close, right? Because it is a paraxial rays and a and p are very close. So n and pn is also very close. So here also we can write also n is very close to p. Therefore, Pn is approximately equal to Cp and Fn is approximately equal to F. So this implies what we got, Cp is equal to 2Fp. So what is Cp? Cp is R and Fp is F. So from here what we got, R equal to P. Understood? Anyone having any doubt, please ask. All of you understood this? How we got
Yes, sir.
R is equal to 2F? All understood? Anyone having doubt, please ask. So it is, you have to remember always the main part. What is the main part of the derivation, or what is the, you can say the the turning point of the derivation is this one. One thing you have to see, there are two main things. One thing is this expression, which is very important if you understand this, and the second thing is these two equations. So if three things you remember, all other things are only mathematics. You can do that. Understood?
Yes, sir.
So this is very important formula. You may ask to derive that. So in that case, you have to use that. Coming back to the same slide. So we have derived R is equal to 2f, that is focal length is half of radius of curvature, and radius of curvature is twice of focal length. Also we know that in case of concave mirror, focal length is negative, and in case of convex mirror, focal length is always positive. So this is the case. Now again, the very important part, that is first I will, what I will do, first I am going to derive the mirror formula. Then I will show you some, if time permits, I will show you some cases how to form images in case of concave mirror as well as convex mirror, right? So first I am deriving mirror formula. Got it? So should I do that? After that, I will explain you how in some cases, like how images are formed in case of concave mirror and convex mirror also. Concave mirror, I have shown you how to form the images, but there are cases when the object is between focal length and all that. So I am going to explain you that after deriving the mirror formula. Mirror formula is very important. So your class will be, I think, till 10. Understand that. Let me derive you mirror formula. Should we derive mirror formula? Is something? I'm going to the derivation part first. this. So we all know what is mirror formula. We know that for mirror 1 plus V plus 1 by U is equal to 1 by F. So what is V? V is the image distance. And what is U? U is the object distance. And what is F? F we all know, the focal length. Now how to derive it? That is the very important thing. So we will start with mirror again. Suppose we have a concave mirror. So this is the focus. This is the center of curvature. There is a point object O. Light ray comes like this. The line from the center of curvature. So suppose this is object O and its image is formed by the concave mirror at I. Suppose the object distance is U and image distance is V. Suppose this is the pole. Suppose this angle is alpha. So take this angle as alpha. I will take this angle is theta. Image is making angle theta and suppose this angle is gamma. So a light ray is incident on the mirror M. The object is O and its image is I. And suppose the angle made by the rays alpha, beta and gamma as shown in the figure. Now what we will do? Draw a perpendicular N on the principal axis. Now again we will apply the geometry here. So suppose this angle is theta, so obviously this angle will also be theta. Now from the diagram, what we can say that beta will be equal to alpha plus theta, right? Beta is the exterior angle. So if you see in the triangle CMI, you can say beta will be equal to alpha plus theta. Also, this angle is gamma I. This angle is basically gamma, right? This angle. So now from the triangle beta is equal to gamma plus theta. Beta will be equal to gamma. Beta we can write gamma plus theta, and gamma can be written as alpha plus theta, right? So from here, from 1 and 2, if you see equation 1 and 2, so what we can write from 1 and 2? From 1 and 2, what we can write? We can write beta minus, we will replace gamma, so beta minus theta will be equal to alpha plus theta, right? So from here you can write beta minus alpha will be equal to 2 theta. Now since the rays are paraxial, so you can write theta approximately equal to tan theta. Beta can approximately be written equal to tan beta, and alpha can approximately be equal to tan alpha. From there, what we can write? Tan beta plus tan alpha equal to tan 2 theta, right? 2 tan theta, sorry, 2 tan theta. So tan beta minus tan alpha will be equal to 2 tan. Now from the figure, what we can write? Tan beta. Well, what will be the tan beta? You see here, what is tan beta? Tan beta can be written as, see the diagram, Mn. Tan beta will be Mn divided by Ti and minus tan alpha. What will be tan alpha? Tan alpha will be Mn upon On equal to 2 tan theta. Tan theta will be equal to so we got beta, we got tan theta we cannot write. Basically, we have to reduce theta, not gamma, right? So from here, what we can do, it's better to remove theta, not gamma. So from here, you can write, you can modify the equation here. How do this? So from the diagram, we have to remove theta. So what we can write, beta minus gamma will be equal to, beta minus gamma will be equal to gamma minus alpha. So from here you can write beta plus alpha. Beta plus alpha will be equal to 2 gamma. So now it's better to write gamma. Here also you can write gamma. Gamma will be approximately equal to tan gamma. Now you can put here tan beta plus tan alpha will be equal to 2 tan gamma. Tan gamma. Now it is okay. Tan beta, what we can write? Tan beta is okay. Tan alpha is also okay. We have written it. And what is tan gamma? Tan gamma can be written as Mn by, tan gamma will be Mn by Nc. Almost of the thing is over. Only 5 minutes. Can you please do? So what is Mn? Mn is common throughout. So Mn will be cancelled out. So now what is the tan beta we have written as? Tan beta is written as actually this is Ni. Now Mn will be cancelled out throughout. So you will get 1 by Ni plus 1 by On will be equal to 2 by Nc. Now put the values. What is Ni? Ni is the Ni will be approximately equal to Pi. So you can write 1 by Pi equal to 1 by OP, that is equal to 2 by PC, right? N and P are very close, so NC can be written as PC. Now what is Pi? This is the image distance minus V. And what is OP? This is the object distance minus U. And what is PC? That is radius of curvature minus R. So from here what you will get, 1 by V plus 1 by U is equal to 2 by R, and that is 1 by R. So 1 by V plus 1 by U is equal to 1 by V plus 1 by U. Anyone having any doubt, please ask. So the other things you can write, like the object is O, image is I. So anyone having in the conceptual part, anyone having any doubt, please ask.
Sir, can you show that for reflection also?
This one?
No, refraction, sir.
Diffraction?
Yes, sir.
You understood this one?
Yes, sir.
All right. So for today's topics only, I have told to, we don't have much time for reflection,
Yes, sir.
diffraction. So for today, I have told only to teach up to reflection only. So this part you understood? Anyone having any doubt? You understood this one, how to derive this? This derivation, all of you understood how we have derived it? Very easy. Only if you remember these two things, you can do it easily. You have to write these two equations, remove theta from both equations. You will get the relation this, beta plus, and then put the values. You will easily get this.